Welcome to all of you, dear students. Once again, I am here with the paper of Business Mathematics and Statistics 2013 for BCOM 1, University of Sargodha. Here I am going to discuss with you about the solution of this paper. So first question, as usual, about the short questions. Relative dispersion. Relative dispersion is the percentage term of absolute dispersion. We calculate absolute dispersion to measure the dispersion of the data in the form of unit. For example, range, quartile deviation, mean deviation, standard deviation. These are all types of absolute dispersion. To represent all these in percentage form, we calculate the relative dispersion. And for example, standard deviation is a measure of dispersion, absolute measure of dispersion, but coefficient of standard deviation will be relative measure of dispersion. Similarly, variance is an absolute dispersion, measure of dispersion, but coefficient of variation will be a relative dispersion. The next one is probability. Probability is the statistical measure which calculates the chance of happening something or not happening something, or occurrence or non-occurrence. Its answer always ranges from 0 to 1. So, third one is classification. Classification is simply the conversion of the ungrouped data into grouped data, or it is simply present the data into rows and columns, or in tabular form having rows and columns. Fourth one is a set of random variable. A set of numerical values assigned to all possible outcomes of the random experiment is called random variable. For example, in a single throw of die, there are 6 outcomes. 1, 2, 3, 4, 5, 6 is a random variable. Random variable must be in numeric form. The next one is transpose of matrix. Simply changing the order of rows or columns of matrix is called the transpose of that matrix. For example, if A matrix is 2, 3, 1, 2, 3, 8, if we change the order of the matrix A, for example, if this column is represented into the row and this column is represented in the row, then this matrix will be a transpose of this matrix. The next question is a function. A function is a special relationship where each input has a single output. It is often written as function of x, where x is the input value, and there are a lot of functions you calculate in your daily mathematical equations. So the next one is annuity. Accumulation of amount or investment in series of payments or deposits after a fixed period of time at certain rate of interest is called an annuity. There are a lot of numerical questions we already discussed in previous papers, and I think in this paper there must be a question of an annuity. Annuity is a case of time value of money in which there are multiple receipts and multiple deposits. So all those cases will be treated as annuity cases in those if this phenomena is present. Coefficient of variation express the standard deviation as a percentage in terms I already discussed in, I think, absolute or relative dispersion in previous question. Coefficient of variation expresses the standard deviation as a percentage in terms of arithmetic mean. It is used as a criterion of consistent performance. The smaller coefficient of variation and the more consistent in the performance, or coefficient of variation is used to compare the variability of 2 or more than 2 series. Formula for coefficient of variation is equals to standard deviation divided by mean multiplied by 100. The next one is skewness. Skewness. What is skewness? If mean, median and mode all are equal, then it means there is no skewness in the data. But if mean, median and mode are not equal, or we can say if their answers are not equal, then it means there is a skewness in the data, and skewness may be positive or negative. If mean is greater than median and median is greater than mode, then there is a positive skewness, and in reverse case there is a negative skewness. Square matrix. In mathematics, a square matrix is a matrix with the same number of rows and columns, and n by n matrix is known as a square matrix of order n. Any two square matrices of the same order can be added and multiplied. Square matrices are often used to present simple linear transformation such as shearing or rotation. For example, there are two examples of square matrix are given here. Compound interest, we already discussed compound interest in the previous paper. It is also a topic of time value of money. Compound interest, there is only one deposit or one receipt. There are no multiple deposits and no multiple receipts in this case. And the one thing which is important to understand while discussing or understanding compound interest, that in simple interest in each time period, interest will be calculated on the principal amount. But in case of compound interest will be calculated on the recent balance of the amount. The next one is mode. Mode, as you know, is a type of average. In ungrouped data is the most repeated value, and in group data it is equals to L plus Fm minus F1 divided by Fm minus F1 plus Fm minus F2 multiplied by H, where L stands for lower class boundary, Fm is maximum frequency, F1 is the frequency which is before maximum frequency, and F2 is the frequency which is after the maximum frequency, and H is the difference of X values. Now we move to the section number 1, question number 2. The following data given: the average monthly wages in rupees of workers in Mushtaq and Company. Data is given here, wages of workers, their slabs are given here, 140 to 145, 145 to 150 and so on. There is no need to calculate the class boundaries because these indicated values are same, as you are seeing here, that if these indicated values are same, then you do not need to calculate the class boundaries. Class boundaries are used in the calculation of median, quartile, decile, percentiles and mode, and we do not need here class boundaries in fact, because we are going to calculate arithmetic mean, geometric mean and harmonic mean. For ungrouped data, arithmetic mean is equals to the sum of fx over sum of f. Harmonic mean is equals to sum of f over sum of f by x, and geometric mean is equals to the anti-log multiplied by sum of f log x over sum of f. Now we move to the calculation. First column represents the classes, second column represents the frequency, which is already given in the question. Here, according to formula, we need different calculations. First of all, we need class mark x. So what is x? Lot of time I discussed with you that just simply add up the two class boundaries and divide it by 2. So 145 plus 140 divided by 2 equals to 142.5, and here you are seeing that there is a difference of 5. So you do not need to calculate next class marks, just simply add up this h, and h is 5. So 142.5 plus 5, 147.5 plus 5, 152.5, so h is 5. After that we need different calculations. We need product of fx, we need sum of f, we need sum of f multiplied by log x, and we need sum of f by x. So just simply calculate these values. First of all, take the product of fx, f multiplied by x. Sum is given here 8565. F by x, f divided by x. So 1 divided by 142.5 equals to 0.007. 3 divided by 147.5 equals to 0.0203, and so on. And the result is equals to 0.2935. After that, we need log of x. So first of all, we take the log values of each x value, and after that we just multiply each log of x with its respective f. So here you can see and you can use these values finally into the formulas, and our arithmetic mean will be 171.3, geometric mean will be 170.8441, and harmonic mean will be 170.3577. Question number 3, part A, define range, mean deviation and standard deviation. Range, mean deviation and standard deviation. First of all these three are the measures of dispersion. Secondly, these three are the measures of an absolute dispersion. Now what is remaining is to discuss about the formulas. The range is simple measure of dispersion. It is denoted as the difference between the largest and smallest observation in set of data. So range is equals to xm minus x naught, maximum value of x minus minimum value of x. Mean deviation is the deviation of each x value from its mean. So we calculate absolute dispersion to measure the dispersion of the data in the form of unit. For example, range, quartile deviation, mean deviation and standard deviation. All these are the types of absolute dispersion. Standard deviation is also a measure of dispersion, which calculates the disbursement of the data, or you can see the spread of the data or scatteredness of the data on the plot. So formula for ungrouped data, which we already used in different calculations, but formula is given here for ungrouped data, and for grouped data formula is this. Part B is the following are the scores made by two batsmen A and B in a series of innings. Who's better as a run getter, who is more consistent player? It is very interesting question. That first of all, we take the mean of these two batsmen's scores. So mean of first batsman's score is 40 and mean of second batsman's score is 33.6. If we only use the average and analyze the mean scores of these two batsmen, then it is shown here that batsman A is better than batsman B. But hold on, this will not be a right decision. First of all, we will calculate the variance, because variance defines the dispersion of this data, and more variance indicates the more risk. So variance of first batsman is, as the data is given here, you can very easily calculate this. The variance is 1349.8 and the variance of the second batsman is 560.24. So on the basis of variance, we can say that batsman B is more better than batsman A, because variance of batsman 1 is 1349.8, which indicates that this batsman is too much risky, because there is a very lot of variation in the scores of this batsman. So it means he can out on 0, he can out on maybe 7, or in the next match he can make 70 runs or 80 runs. So player A will be risky. Question number 4, part A. The following are the figures of sales and profits of a manufacturing concern for 2 year. Calculate coefficient of correlation. We already calculate lot of times the correlation coefficient in previous questions. Simply take two variables here, x and y, and apply this formula. We need here mean of x, we need here mean of y, we need here standard deviation of x and standard deviation of y. So lot of time I told you that in the correlation and regression questions we need these 5 calculations. We need sum of x, we need sum of y, we need sum of xy, we need sum of x square, and we need sum of y square, and the sum of all these calculations are given here. So we just simply put up all these calculations into the formulas. Mean of x is 131 divided by 9, 14.56. Mean of y is 33.56. After putting the values in the standard deviation formula, the standard deviation of x will be 3.545, and after putting the values in the standard deviation of y formula, the standard deviation of y will be 10.336. And finally put these values into the correlation formula, and correlation will be 0.892, which indicates that there is a positive relation between these two variables. Part B is the following are the price and quantities of 2 years for the commodities. Calculate index number by using Lespez method and purchase method. Something is hidden behind the table, so I just want to change the location or drag it down. So right here we need to calculate the index number by using Lespez and purchase method. We already discussed this type of question in previous paper too. So first period price and quantity will be base price. So price of 1980 will be P naught and quantity of 1980 will be Q naught. Similarly, price of current period will be P1 and quantity of current period will be Q1. And we need 4 calculations here: P1 Q naught, P naught Q naught, P naught Q1, and P1 Q1. Just simply multiply the respective columns. For example, P1 Q naught, so P1 is here and Q naught is here. So 110 multiplied by 32, 3520. P naught Q naught 30 multiplied by 110, 3300. Finally P naught Q1, P naught and Q1 112 multiplied by 30 equals to 3360. P1 Q1 32 multiplied by 112, 3584, and so on. And some of these are 9020, 8950, 10260, 10274. And after that just put the values into the formulas. Lespez index number is always equals to sum of P1 Q naught divided by sum of P naught Q naught multiplied by 100, and purchase index number is always equals to sum of P1 Q1 divided by sum of P naught Q1 multiplied by 100. So just simply put up all these values into the two formulas. So Lespez index will be 100.7821 and purchase index will be 100.1364. It means that according to Lespez index into 1981 there is 0.7821% inflation, and according to purchase index in 1981 there is an inflation of 0.1364. Question number 5. 3 coins are tossed. What is the probability of getting exactly 2 heads, at least 2 heads, at most 2 heads? First of all, we need to take the sample space, which is equals to the aspects raised to power count. As you know that in coin there are 2 aspects, head and tail, and number of coins are 3, so 2 raised to power 3 equals to 8. And all possible outcomes, that what are these all possible outcomes? First of all, write down 3 times head. After that, place tail at the end, and after that just drag it to the left. This tail should be dragged to the left, and finally tail, head, head, and in this row just change the head with tail or tail with head. So these are 8 possible outcomes. So next step is to allocate the events. First question is 2 heads, and exactly 2 heads will be indicated by A, and there are 3 possible outcomes in which there are exactly 2 heads, 1, 2 and 3. After that, at least 2 heads. At least 2 head mean there may be 3 heads. So 1, 2, 3 and 4. So there are 4 possible outcomes. And third one is at most 2 heads. So it means that maximum 2 heads. So in maximum 2 heads, there may be 1 head. So 1, 2, 3. At most 2 heads. So 0, 1 and 2. 0, 1 and 2. So there are 7 possible heads. These are not 6. 0 also be counted. So, and after that, just simply to calculate the probability is always equals to sample space event divided by sample space. So first event is 3 and sample space is 8, so 3 by 8, 0.375. The second one is event of B is 4 divided by 8 is 0.5, and third one is equals to 7 by 8. So 7 by 8 will be equals to will be equals to 0.875. So 0.875. So that will be correct answer. After that, now we move to the B part. 2 fair dice are thrown. What is the probability of getting? The sum of the face is 5. The sum of the face is 10 or more. A product of numbers on 2 dice is 12. So here, according to the question, we also need sum table and we also need the product table. First of all, first important thing is to calculate the sample space. As in previous question, I already discussed that it is equals to the aspect raised to power count. So 2 fair dice, so it means count is 2 and there are 6 aspects of die, 1, 2, 3, 4, 5, 6. So 6 raised to power 2 will be 36, and these 36 possible outcomes are given here. Method is very simple. Write down 6 times 1, write down 6 times 2, write down 6 times 3, write down 6 times 4, write down 6 times 5, write down 6 times 6. And after that, just place 1 to 6 with each. For example, 1 to 6 with 1, 1 to 6 with 2, 1 to 6 with 3, 1 to 6 with 4, 5 and 6. So these are 36 possible outcomes in case of 2 fair dice are thrown. After that, we need sum table and product table. Sum is very simple to calculate, that 1 plus 1 is equals to 2, 2 plus 1 plus 2, 3, 4, 5, 6, 7. Similarly, 2 plus 1 is 3, 2 plus 2 is 4, 3 plus 1 is 4, and 4 plus 1 is 5, 5 plus 1 is 6, and 6 plus 1 is 7, and similarly you can calculate the sum table. Product is, as you know well, that it is the multiplication. So 1 multiplied by 1 is 1, 2 multiplied by 1 is 2, 3 multiplied by 1 is 3, 2 multiplied by 1, 2, 2 2s are 4, 2 3s are 6. Similarly, 3 1s are 3 and 4 1s are 4 and so on. So these are 3 tables. The next thing is the allocation of event. So what is the event? Event are those possibilities, those are asked in the question. First event will be the sum of the faces 5. So in sum table you can search that sum is 5, 1, 2, 3 and 4. So first event will be 4. Now after that the second event will be the sum of the faces 10 or more. So sum is 10, 1, 2, 3 and or more. So it means 11 also be counted and 12 also be counted. So 3 plus 3 will be 6. Third is a product of numbers on 2 dice is 12. Product of number is on 2 dice is 12. So product is 12 as it is given here. This one, this product is 12. After that this product is 12, this is 12, and this one is 12. So there are 4. And third step is to calculate the probability, which is equals to event divided by sample space. So 4 by 36 0.12, 4 by 6 by 36 0.167 and 4 by 36 0.12. Section 2, question number 6, part A, solve for x and y. One equation is 2x plus 5y equals to 30. Second one is 3x minus 2y equals to 7. Similarly, one more question here, 2x plus 5y equals to 30 and 3x minus 2y equals to 7. 2x plus 5y, okay, right. It is also written one time more. So the question is 2x plus 5y equals to 30 and 3x minus 2y equals to 7. So this will be equation number 1, this will be equation number 2, and we need here to cancel one variable to calculate the other variable. So how can we do this? Simple, here we want to cancel this x. So method is very simple, that first equation should be multiplied by 3 and second equation must be multiplied by 2 to eliminate this x. After doing this, first equation will be 6x plus 15 y equals to 90 and second equation will be 6x minus 4y equals to 14. Just change the signs, minus, plus and minus. 6x will be cancelled, 15y plus 4y will be 15y plus 4y will be equals to 19y equals to 76, and 76 divided by 19, it will be equals to 4. So put y equals to 4 in any equation to get x. For example, 3x minus 2y equals to 7, 3x minus 2 multiplied by 4. So it will be equals to 3x minus 8. And this minus 8, when it goes to the other side of the equation, it will become plus 8. And 3x should be equals to 15, and x will be equals to 15 divided by 3, and the answer will be 5. So x will be 5 and y will be equals to 4. So that is the correct answer. After that, we move to the B part. The length of a rectangle is 5 meters more than its width. If the perimeter is 60 meters, find the dimension of the rectangle. Here, assuming that you mean the field is a rectangle, let the width be x, the length will be x plus 5, because it is given in the question that length of rectangle is 5 meter more than its width. So if width is x, then length will be x plus 5, and the perimeter will be length plus width plus length plus width. So x plus 5 plus x plus x plus 5 plus x equals to 4x plus 10. We know the total perimeter is 60, so we have 4x plus 10 equals to 60, or 4x equals to 60 minus 10, or finally x will be equals to 12.45. So the width will be 12.5 meters and length will be x plus 5, or we can say 17.5 meters. Here you can prove this after calculation. You can just put up these values into this formula. Question number 7. If A matrix 3, 5, 4, 2, 6, 5, 1, 3, 7, B matrix 1, minus 1, 4, minus 3, 8, minus 2, 5, 3, 5, 6, then find A plus B, second A minus B, and third A B. In the calculation of addition, just simply add up the same elements. So first element plus first element of B matrix, second element of A matrix plus second element of B matrix as it is given here. And in the case of subtraction, we just reverse the case, that first element of A matrix minus first element of B matrix, second matrix element of A matrix minus second element of B matrix, and so on. So A plus B is given here. Calculation 291, 10, 4, 10, 4, 8, 13, and A minus B is equals to 417 minus 680 minus 2 minus 2 1. Multiplication is already done in the previous paper, but once again I can tell you that first row multiply by first column, first row multiply by first column given here. After that, first row multiply by second column, which is given here. First row multiply by third column, which is given here. Second row multiply by first, second row multiply by second, second row multiply by third column, which is given here. And finally third row multiply by first column, third row multiply by second, and third row multiply by third column, which is given here. And all the calculations are given here. You can pause the video and see the calculation, and AB finally will be equals to 49, 22, 40, 61, 21, 54, 44, 33, 54. Question number 8, that solve the equation by quadratic formula. 6x square minus 13x plus 6. A will be 6, B will be minus 13, C will be 6. Just put up these values into this quadratic formula and you can solve the x. Find the compound interest on rupees 4,000. Principal amount is 4,000 for 1 year at 8% payable quarterly. So interest rate is 8%, but case is the quarterly basis. So 8 divided by 4 will be 2%, and there are 4 quarters in 1 year, so n will be 4. Just put up these values into the formula of compound interest, which is equals to p multiplied by 1 plus I raised to power n minus p, and compound interest will be 329.6. Question number 5 part A, that if rupees 200 invested each year at 5% interest compounded annually, what would be the total amount of the investment after 10 years? So future value is required here. It is the case of multiple payments. So if 200 invested each year indicates that it is the multiple payment based case. So 200 will be R. Here we will apply the annuity method. Future value is required, so 200 will be R, and interest is 5% compounded annually. Interest will be 0.05, and what would be the total amount of the investment after 10 years? N will be 10. Future value formula is given here. R multiplied by 1 plus I raised to power n minus 1 divided by I. Just simply put up all these values into this formula, and future value will be 2515.6. B part, that find the amount of annuity of rupees 500 payable at the end of each year. Once again, it is the case of an ordinary annuity. 500 will be R. If the interest rate is 6% compounded annually, interest rate will be 0.06 and N will be 10. Same formula once again we will apply here. Just put up the values and the future value will be 6590. So it was the paper of 2013, University of Sargodha. Soon I will come with the other papers. So stay blessed, stay safe, and take care of your surrounded peoples and your respondents, and thank you very much.